In episode 25 of the Junior PenTester training series, we are going to continue with our network security module, and we're going to learn more about Nmap. And in this particular video, we're going to be talking about the basic port scanning capabilities of Nmap and how we're going to do the Nmap TCP Connect Scan, the TCP SYN port scan, and of course UDP port scans. And this is all available through the TryHackMe platform. And this specific room, as you can see right here, is going to obviously provide their introduction for us. We have TCP, UDP ports, TCP flags. These are just kind of explanation portions just so you understand what they look like and what you're looking for when you do your scans. And then we have 3 virtual machines that have been assigned to us that we're going to use to get the Connect Scan, the SYN Scan, and the UDP Scan completed. And then from there, we will talk about fine-tuning and scope performance, and then of course the summary and final thoughts and all of that good stuff, and then you will be dismissed for the day. And so the room is again available through the TryHackMe platform. It was created by Strategos, still don't know exactly how to pronounce their username, but shout out to that person for creating this room for us so that we can use it. This is a subscriber only room that's available in TryHackMe, meaning you actually do need a paid membership. However, if you have Nmap installed on your own computer, or if you have Kali Linux, which I love, and we're going to be using a Linux machine that has Nmap installed on it, you can then just go ahead and run along with me as we go ahead and do these scans, and then you'll be able to practice Nmap on your own computer. So this isn't necessarily mean that you need to have TryHackMe. I will say that when you do your Nmap scanning, just do it against your own cell phone or your own, other computer. I have multiple computers inside my studio. So do it against your other computers or do it against your cell phone or another machine that you have. Don't do it against somebody that hasn't give you permission to do it. And this is the reason why I use TryHackMe or services like TryHackMe, mainly because of the fact that they provide these virtual machines for us to scan without getting into legal trouble, because again, it is a felony and it's a big issue if you do this without permission. So just wanted to give you that full disclosure. But apart from that, it should be a pretty straightforward video today. It should be a pretty straightforward episode, and hopefully you will get a lot of value out of it. A quick shout out from Hackaholics Anonymous, and we'll dive deep into the contents. If you're serious about your SysAdmin education and you want access to me on Discord, consider joining Hackaholics Anonymous. We have 4 tiers: the supporter, agent, guardian, and master. Each tier gets their own Discord server and early access to content. The agent, guardian, and master levels get exclusive content, exclusive downloads, monthly Python automations, live streams with me every month, plus so much more. And to join, you can simply click the link in the description below, or you can go to our homepage and click the join button there, or you can go to youtube.com/@HankHacksHackers/join, and you will be able to join Hackaholics Anonymous. Now, without further ado, let's jump into the Nmap basic port scans. Okay, so this episode is the second in the Nmap series. So we did the live host discovery in the very last episode. Basic port scans is what we're going to be doing today. Then the next video is going to be advanced port scans, and then the post port scans. So in the previous video, the one that we did right before this one, we have covered the focusing on online systems, right? And now we're going to have 3 steps in this particular process, which is the enumeration of the targets, discovering live hosts, and of course reverse DNS lookup. So this is what the full thing looks like here. I'm kind of zoomed in on the screen, but enumerating target, discovering live hosts, and reverse DNS is basically what we talked about previously. So now we're going to go into actually scanning ports. So the next series of steps would be the port scan for TCP Connect port, and then we have another one for the SYN port scan, and then we have the UDP port scan. So you have TCP Connect and SYN, which are essentially scan types. And then we have the UDP port scan, which is essentially a different protocol on the transport layer that we will be using to try to find open ports. So we are going to discuss the different options to specify the ports that we want to scan, the actual rate of the scan, and of course the number of parallel probes that should be sent out, that will make the scan go a little bit faster for you. And all of that stuff will be discussed in addition to actually doing these types of scans that we have. Sorry, I kind of went off the screen here. So we're going to launch the attack box, which I've already done. The virtual machine is also launched. The very first target machine is also launched. So we should be ready by the time that we actually get to that portion of it. And now let's dive into the difference between TCP and UDP ports. Okay, so here's the read-through. In the same sense that an IP address specifies a host on a network, among many others, a TCP port or a UDP port is used to identify a network service that's running on that host. So a server provides the network service and it adheres to a specific protocol. An example would be the time, for example, responding to DNS inquiries or serving web pages. A port is usually linked to a service using that specific port number. So for instance, HTTP would bind to the TCP port 80. This is a default port for HTTP communications via TCP. If HTTP supports SSL or TLS, which is the secure version of HTTP, then it would be on port 443 and it converts it into HTTPS, which is what you see right here. So in conjunction to these ports, port 80 and 443 are the default ports of HTTP and HTTPS. However, the web server admin might choose other port numbers if necessary because it's pretty well known in the networking world that 80 and 443 are relative to HTTP and the secure version of it. So maybe the network admin or the web server admin wants to be more secure, so they change it from the default ports into a different port. So no more than one service can listen on any TCP or UDP port on the same IP address at least, right? So we have 65,000 plus ports that are available on every single IP address. And so if you have, more than 65,000 services running in your company, then maybe you should use multiple IP addresses. But pretty much on any given IP address, you have a 65,650, something like that. I know it's more than 65,000. That much I know for sure. And they're a combination of TCP and UDP ports. So at the risk of oversimplification, we can classify the ports in two states. You have open ports that indicate that there's some service listening on the port, and then you have a closed port that indicates there's no service listening on the port. Now, this is, again, an oversimplification. There are filtered ports, right? So if they're behind a firewall, it could be open, but the firewall might be blocking the packets. Therefore, Nmap considers the following 6 states. It has open, it has closed, it has filtered, unfiltered, open filtered, and closed filtered. So open is the services listening on the specified port. Closed indicates that there's no services listening on the port, although the port is accessible, right? So it's closed, but it is accessible. By accessible, we mean that it's reachable and is not blocked by a firewall or other security appliance, right? So if you see closed, it's accessible, it's just there's nothing listening on it, right? Filtered means that Nmap can't determine if the port is open or closed because the port is not accessible. So it's usually due to a firewall, typically, preventing Nmap from reaching that port, and the packets may be blocked from reaching the port. Alternatively, the response are blocked from reaching Nmap's host, which essentially says that it's filtered. If we see filtered, it typically means that it is open, but it's sitting behind a firewall. It's not the case all the time, but that's kind of what it means. Unfiltered means that Nmap can't determine if it's open or closed, although the port is accessible. This state is encountered when using the ACK scan, also known as lowercase s, uppercase a. And then we have the open filtered and closed filtered. So open filtered means that Nmap can't determine whether the port is open or filtered. Closed filtered means that Nmap can't determine whether it's closed or filtered, right? So these are the 6 states. For the most part, I have seen these 3 pretty much all the time. Unfiltered, I really don't see. Open filtered or closed filtered, I rarely see. But I usually do see open, closed, and filtered pretty much all the time. So which service uses UDP port 53 by default? And I just know this off the top of my head. And so that would be DNS, as long as my keyboard works. There we go. So DNS. Which service uses 22 by default? That would be SSH. And how many port states does Nmap consider? 6 total port states. And which port state is the most interesting to discover as a pen tester, and of course that would be the open port state. Now, when you see things like this, the 53 by default or 22 or whatever it is, these are things that I have seen so many times that I know what they are off the top of my head, but it wasn't like that at the very beginning. I studied networking. I even launched a networking course, CompTIA Network Plus, that's available on this on this channel, so you can go ahead and check that out. And it's like a really good, it gives you a good overview introduction, but then it also goes into the deeper and more advanced topics behind networking, and it has practical videos and a bunch of other stuff as well. So for your intensive purposes, you can always find cheat sheets of the most commonly used ports, and you can find out what services are running on those ports, and you can just Google them. There's so many free ones that are available, and I highly recommend them. So if you don't know what these ports are off the top of your head, it would be something that you should consider studying, because it would help you become a better security professional, a better hacking professional, so on and so forth. But anytime that you do a scan, if you see that a port is open and you don't know what it is, you can always just Google it, and then based on that, you can continue the rest of your reconnaissance. Okay, so let's talk about TCP flags. To be able to understand the different types of port scans that are available, we need to first understand what a TCP header is, and we need to review the portion of the TCP header that is relevant to this. And that's actually the first 24 bytes of a TCP header. So the figure that we have below right here is going to show us the TCP header as defined in the RFC 793, and RFC 793 is basically a code. So this is, what is this? We have the data tracker datatracker.ietf.org, and then they have this this document that's available for us that essentially outlines this thing for us, and it's an internet standard. So the RFC stands for, let's see if we can find the acronym here, for Transmission Control Protocol is TCP, of course. RFC, let's say I can just probably Google this, and I can just do this right here, and then we'll search Google for it to see what it stands for. Transmission Control Protocol, RFC. What does RFC stand for? It's the internet standards. However, I'm just trying to find out what RFC stands for, bro. So let's see. We might actually have to do it. What does RFC stand for? There we go. For in networking, we'll even get more specific with that. So it stands for Request for Comments. Oh my God, really? Seriously, dude? So it stands for Request for Comments. RFCs are a series of documents published by the Internet Engineering Task Force and other standard bodies that describe protocols, concepts, and methods related to Internet and yada, yada, yada. Okay, so RFC 793 is basically an Internet standard that has to do with transmission control protocol, and it's a request for comments, I guess, something that people can add their stuff to. So anyways, this figure may look sophisticated, but it's pretty simple to understand. In the first row, we have the source TCP port number and the destination port number, which is this piece right here. So source port and destination port. So where it's coming from, where it's going. That's basically what it is. We can see that the port number is allocated 16 bits, which is 2 bytes. So this line, let me see if I can kind of zoom out of this so you can see the full thing. So you see it goes from 0 and it goes all the way to the end right here, and this is 32. So we have 32 bits in total. And so 32 bits, each byte is 8 bits. So if you have 2 bytes, that means it's 16 bits. So the source port is 16 bits and the destination port is 16 bits. So you can see that right here. Then we have a sequence number and an acknowledgement number. So we can see the port number is allocated da-da-da. In the second and third rows, we have the sequence and the acknowledgement number. Each row has 32 bits or 4 bytes that are allocated to it, with 6 rows totaling, making up 24 bytes that are available. So we have 1, 2, 3, 4, 5, 6, 7. This is actually 7 row. So I guess not counting the ports at the top, we should have 1, 2, 3, 4, 5, 6. Technically, I guess, I don't know if that's what they meant, but that's basically what it is. And then at the very, very bottom, you can also see this piece right here. It's kind of harder to see, but it says byte 0, byte 1, byte 2, and byte 3. So it starts with the index position 0, which is typically what it's done in coding and networking. So you can use it essentially the same way. If you're familiar with coding, you can hopefully just decipher that, but really it's not really complicated. It's just instead of starting at 1, it starts at 0. So byte 0 would be index position 1, or index position 0, I guess, but technically it's the first position, and then you have 1, 2, and 3, and each byte is 8 bits, as you can see. That's pretty much it, right? That's all you need. So what we need to focus on are the flags that Nmap can set or unset. And we've highlighted the TCP flags in red, which are these pieces right here. So notice that they are assigned 1 bit each. So if the URG flag or the urgent flag has been set, that means there's been 1 bit that has been assigned to it. You have the acknowledgement flag, the push flag, the reset flag, the SYN flag, and the FIN flag that have been set, right? So if you set the flag, it means that you're setting the value to 1. From left to right, you have these. The urgent flag indicates that the urgent pointer filed is significant. The urgent pointer indicates that the incoming data is urgent and that a TCP segment with the URG flag is processed immediately without consideration of having to wait on a previously sent TCP segment. So as the name implies, it's urgent, process it before you do anything else, right? That's what we're telling the network. The ACK flag, also known as acknowledgement, indicates that the acknowledgement number is significant if it is used to acknowledge the receipt of, or it is, excuse me, not if it is used to acknowledge the receipt of a TCP segment. Push flag asks the TCP to pass the data to the application promptly. The reset flag is used to reset the connection or basically end the connection. Another device like a firewall might send it to tear a TCP connection down. This is also used when the data is sent to a host and there is no service on the receiving end to answer. The synchronize flag is used to initiate the TCP three-way handshake and synchronize sequence numbers with other hosts. The sequence number should be sent randomly during the TCP connection establishment. And then the FIN flag is when the sender has no more data to send. So it's finished, right? You're finished sending data, basically. So what 3 letters represent the reset flag? That would be the RST. Which flag needs to be set when you initiate a TCP connection? The first packet of the three-way handshake, and that is the synchronize flag that we need to set. So let's now do the Connect Scan. So now we're actually going to do a scan with Nmap, and we're going to try to establish the Connect Scan. The Connect Scan works by completing the three-way handshake. Okay, so this is what the three-way handshake looks like. So you have the SYN flag, the synchronized flag, that's sent first. It's sent from the client, which is you in this case, and it's being sent to the server, okay? The server will respond with an acknowledgement. It says, I acknowledge your synchronization. So SYN and ACK are both set. So the first one that's sent just has the SYN flag sent. The next one that comes back has SYN and an acknowledgement both set. And then finally, the client will send another one saying final acknowledgement, great. And once this one is sent and received on this end, we now have a completed three-way handshake and the TCP connection has been established. So when the TCP connection is established, it's the loudest type of scan that we do with Nmap. However, and I should say not necessarily however, it's like it is the loudest one, meaning that it shows up on network scanning and network monitoring devices because we're literally establishing a full connection with the end server and the agent is going to be Nmap, so they're going to be alerted, and it's a very loud scan. And the reason why we would do this is because this is the most informative scan that we can do. So if we do a TCP Connect Scan and we actually establish a connection with the server, with the host that we're trying to connect to, we're going to get as much information as we possibly can using Nmap. So it is the loudest. It's also the most informative. And so if we do something that's quiet, so for example, doing a stealth scan, then we're not going to get as much information, right? So that's the key element of doing a full connect scan versus just doing a stealth scan. The stealth scan will tell you, okay, I think these ports are open. It's not as reliable. A TCP Connect Scan, it's already established a full connection. So when it tells you ports are open or something is filtered or whatever, that's the most reliable information that you can get, right? So we are interested in learning whether the TCP port is open, not establishing an actual connection. Hence, the connection is torn as soon as the state is confirmed by sending a reset acknowledgement. And you can choose to run a TCP Connect Scan using the lowercase s, uppercase t. So this is what it will look like, right? So when you do lowercase s, uppercase t, SYN is sent, SYN acknowledgement is received, acknowledgement is sent, and at the same time, the reset acknowledgement is sent just to tear down the connection so that we're not fully connected to this thing or stay connected to it because, again, it's just too loud. But even in this case, it's still going to be loud. So let's just be very clear about that. When you receive the SYN acknowledgement and you complete your connection to it, you are doing the loudest type of scan that's available. So if you're not a privileged user, sudo or root, a TCP Connect Scan is the only possible option that you can use to discover TCP ports, because when you do a SYN or like a stealth scan just by itself, you need to have root permissions or admin privileges to be able to do that kind of a scan. So this is what Wireshark will actually show us. When we have a packet capture window, we see that Nmap is sending TCP packets with the SYN flag sent to these various ports. By default, Nmap will attempt to connect to the 1,000 most common ports unless you declare otherwise. A closed TCP port responds to a SYN packet with an RST acknowledgement and to indicate that it's not open. This pattern will repeat for all of the closed ports as we attempt to initiate the three-way handshake. So we can see this right here. So let's zoom out a little bit. So we can see these right here, right? So these are the source IP addresses, which is essentially us, right? And we're sending all of these SYN. You see these SYN packets that you see right here. We're sending all of them from one of our ports to these other most common ports. So you have 443, 143, 256, 888, 445, etc., port 80, which is HTTP, right? So it's sending all of these requests for synchronization to all of these destination ports. And then the 25227 IP that you see right here, it starts responding, right? So when you see reset acknowledgement, that means that this is closed, right? So reset acknowledgement from 443 means 443 is closed, 256 is closed, 888, 5900, these are all closed, right? And if you see that it receives 252.27, 143 is the port right here. So from the destination right now, or from this initial host that we're trying to connect to, now it's the source, meaning that it's communicating back to us. And it's saying that port 143 is actually open because it's saying synchronization is acknowledged. You see that? And then now we send another packet back to it, and then it's a final acknowledgement packet. And again, it's on port 143. So we are now establishing the connection on port 143. We have a full connection established, and the three-way handshake has been completed, right? So 143 is open. It replied with SYN acknowledgement. Nmap completed the three-way handshake by sending the final acknowledgement, and it shows all the packets exchanged between the host and the target on port 143. You can actually filter your connections, as you can see right here, by looking for that specific IP address of your destination host or the target host, and we're just looking for port 143, and then it only shows the packets for that. So you can see SYN was sent, SYN was acknowledged, acknowledgement was sent, and then the reset was sent to tear that conversation down, to tear that connection down. So to illustrate what this actually looks like, this is what the terminal command line would be. Nmap st, and then we would connect to the target host in this case, and then from there it will respond to us. So it says, 22 is open, 25 is open, 80, 111, 143, 993, 995. These are all open, and it even gives you its best guess on the service, right? So secure shell, SMTP, which is for email that's used, HTTP, which is for internet connection or web browsing, RPC bind, IMAP, IMAP-S, POP3S, POP3S is also used for email. So typically SMTP and POP3 are usually together. So anyways, these are just the open ports that are available. The states, as you can see, these are all open states, and then we have the services that are assigned to them. And then you can just go further and do all these different types of scans that we'll talk about later to get even more information about each one of these open ports and what type of services and versions are running, so on and so forth. So we can use the capital F, so -F, to enable fast mode and decrease the number of scan ports from the 1,000 most common to the 100 most common. And if we use the -R, you can also do that to scan the ports in consecutive order instead of a random order. And it's useful when testing whether ports open in a consistent manner. For instance, when a target boots up, we just want to see if the port is connecting in a consistent consecutive order. So What we're going to do now is we're going to launch the VM, which I've already done, and we're going to run this scan on the virtual machine. And a new service has been installed on this VM since our last scan, as shown in the terminal window above. So since this scan, basically, we're trying to see what the new service is and what the port number is assigned to it, and what's Nmap's guess about the newly installed service. So let me just open this up in a split view, and then we'll open it up in a full screen right here to make it a little bit easier for us. And what we're going to run is essentially an ST scan against this IP address inside of the terminal. So let's go ahead and open up the terminal. We'll drag it to the left a little bit so I can kind of zoom in on this a little bit easier and move around a little bit easier. So here we go. So we're going to do Nmap ST, and then we're going to paste the IP address that we want to scan. Press enter. It runs very quickly. So what do we have? We have 22, 25, 80, 110, 111. I think it's 110 actually, because 110 was missing. So it's POP3, which is the unsecured, unencrypted version of POP3S. So I believe it's 110. So let's go ahead and look at the results here. Yeah, so 110 is missing. So we can go over here. The port is 110, there you go, 110. And then the answer, the best guess here, is POP3. And on port 110, this is the default port for POP3, which is the post office protocol that's used for email. So now we can move on to the next one. Actually, so before we do this, I need to start the next machine. So I'm going to terminate this machine, and we're going to go ahead and start this machine so that it loads while we read through the instructions here. The SYN scan is also known as the stealth scan. So when we do the SYN scan, we're essentially doing the opposite of what a full Connect scan would do. We're trying to be stealthy. We're trying to not make a lot of noise in the network monitoring logs. So it doesn't complete the three-way handshake. Instead, it tears down the connection as soon as it receives a response from the server. So you just send the SYN flag, the SYN packet, right? And because we didn't establish the full TCP connection, this decreases the chances of a scan being logged. And we can select the scan by using the lowercase s, uppercase s option. And so this is what it looks like, right? So SYN flag is sent. The server responds with the acknowledgement, but then we immediately send a reset flag and we tear down the connection. We don't send that final acknowledgement to complete our three-way handshake. Therefore, there is no official connection that's established, and so it's not as loud, right? So this is the screenshot that shows the SYN scan. So again, SYN packets are sent out, and then this is our IP address. This is the destination IP. The destination IP then starts responding to us. And so on this one, it sends the reset. So we know that this is a closed port. Then on port 25, it actually sends a SYN acknowledgement. And immediately we respond back with a reset flag to close that connection. And essentially the same thing goes on for port 80 as well. So it responds saying that port 80 is open, right? So it says, I acknowledge your connection. So if it says SYN acknowledged, that means that port 80 is open or port 25 is open. It's just that we never send that final acknowledgement to do the official connection, right? So the difference would be this specific screenshot that we see right here. So in the upper half of it, we can see the full Connect scan using ST. In the lower half, we'll see the SS, right? So this is what the screenshot looks like. This part right here is the full Connect scan. So it sends the SYN, we send the SYN, they send SYN acknowledgement, we send acknowledgement, and then we send reset. On this one, we send the SYN, they send SYN acknowledgement, and we immediately send the reset. So there is no full connection that gets established. So it's the default scan mode when running Nmap as a privileged user. So you have to use sudo to be able to run it. And it's a very reliable choice because it will respond with the SYN acknowledgement to imply that it is open. It's just that we don't get as much information about our target as we want to. So everything that we found with the TCP Connect Scan can be found, except we just did not establish a full TCP connection. So this is what we see right here. Same thing, 22, 25, 80, 110, 111, 143. These are the things that were opened for this specific IP address. This is the new IP address that I just launched. So what we're going to do now is we're going to run a SYN scan against that IP address, and we're going to try to see what the new port is that has been opened and what the service name would be for that one. So I'm going to just copy this IP address right here, and we're going to go back to our Nmap instance in our terminal here, and we're going to run it again. So it's going to be lowercase s, uppercase s, and then we're going to paste the IP, press enter, it'll run. There you go. So 22, 25, 80, 110, 111, 143, da 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 da. This is the new one. So 6667 and IRC would be the best guess here. So 6667, and then the best guess is IRC. There you go. And just like that, you were able to run a SYN scan, a synchronized scan just by itself. You didn't establish a full TCP connection. So now in order to pull the next one off, we're going to terminate this virtual machine, and we're going to move to the UDP one, and we're going to start that. So let's read through the UDP connection. UDP is actually a connectionless protocol, so I should have probably said it that way, but TCP is usually the protocol that's used when you want to do an official connection to a destination, and then you want to make sure that everything is delivered and you receive everything. So for example, let's say file transfer that you're doing between a cloud drive, right? Let's say Google Drive. So you're trying to transfer a file to Google Drive. You need a TCP connection to that specific domain on the port that's being used to transfer that file, because you want every bit of that file to be transferred to the Google Drive. UDP doesn't require a full connection. So UDP is used for music streaming or for video streaming and things like that. So you will sometimes receive messages, or not messages, I should say data, that's not full. So for example, when you connect to Netflix sometimes, or YouTube or something like that, it's going to be via the UDP, and then you'll see pixelated images, right? Before the connection is fully established and you're receiving all of the data in its entirety for the first 5 to 10 seconds or something like that, you might receive a low quality image until it establishes a stronger connection. Even though it's connectionless, it gets like a stronger connection to the UDP port, and so the images now become a little bit more fine-tuned and higher quality. But it doesn't require a full connection because it doesn't really matter. It's just a video, right? It's not that big of a deal. And in that same spirit, in that same breath, we can say that TCP is slower, UDP is faster, which is why you need UDP for video streaming, because it would take too long for the file to become available, for the stream to become available if you were using TCP, because it requires that full connection. UDP doesn't require a full connection, therefore it starts streaming right away and it ends up being faster, right? So that's kind of like my overview of this for you. So UDP is a connectionless protocol. It does not require any handshake for connection establishment. We can't guarantee that a service is listening on a UDP port and it would respond to our packets. However, if a UDP packet is sent to a closed port, an ICMP, so Internet Control Messaging Protocol, an ICMP port unreachable error, type 3 code 3 is returned. And you can select UDP using SU. Moreover, you can combine it with another type of TCP scan. So this is what it looks like. Basically, it sends a UDP packet. That's it. There's no response. There's nothing that we receive from the server. So if the UDP port is open, no response is expected from it. If the UDP port is closed, then we will get a response saying that the port is unreachable. So that's how we conclude that it's closed. If we don't get a response, we conclude that, oh, it's open, because it didn't explicitly tell us that it was closed. So as shown in the figure below, we can expect to get an ICMP packet destination unreachable if the port is unreachable, right? So we send a UDP, it sends the ICMP type 3 code 3, UDP port is closed because it's the destination, it's unreachable. That's how we determine whether or not it's open or closed. So in this capture, we can see that every closed port will generate the ICMP packet. So this is us on the first column, this is them, we're sending UDP packets, we're sending them to all these different UDP ports, and then the ones that are actually closed, they respond with destination unreachable, right? Very, very simple, really straightforward. So using the scan would require sudo again, and then you would do su. And interestingly enough, I didn't use sudo in this one when we were doing the SS, and it still worked for me. So it implies that I'm already logged in as a sudo user. So just keep that piece in mind, because usually it won't work. It'll respond that you need to use sudo to be able to run it. So this is just automatically implying that I am a sudo user. So what is it? We learned that port 111 was open. So running the UDP scan against Linux, we learned that 111 was open. Nmap cannot determine whether UDP port 68 is open or filtered. So if we do the SU scan right here, we can see open filtered for this 68 UDP. 111 did return to be open, right? So we're going to now run a UDP scan, and we're going to do the fast mode right here with the capital F, and then we're going to do verbose to get a verbose response to see the results of the various port scans as we run it. So usually I actually recommend running the -V at the very least, just so you can get the status of Nmap as it's working. Otherwise, it'll just return whatever ports are open or closed. So in this particular case, we will do the SU, the F, and the V, and we're going to connect to this specific IP, which is the new machine that we launched. So let's go here and let's zoom in, and then we're going to clear the screen, and I'll do sudo nmap. Let's see if it's going to work. So su-f-v, and I'm going to paste the IP address here. Let's see if it'll ask me for a password. It doesn't. I'm an admin. That's basically what it says. So notice how, because we used -v, notice how it's actually showing the results for everything that it's doing, right? So from 0 to 50, 50 to 100, max increase to 5, 6, 7, etc. So it just keeps going, and it's going to scan whatever we need it to until it gives the response that we're looking for, that final response that we're looking for with all of the open ports, or the ports that might be open filtered or unreachable, etc. So I'm going to let this thing finish. It's approximately 44% done, as you can see right here. And once it's finished, we will come back and view the results. Okay, so it's done, and notice that before it gave me the final report right here, it actually started saying discovered open port 111, 53, things like that, right? So it actually tells you what it discovers as it goes. So we have 3 ports that are open right now, or actually 2 are fully open, and one of them is open filtered, as you can see right here. So the question asks us what? It says, what is the UDP port that is now open based on these? So 68, 111, and so what do we have? We have 53 is the new one. So 53 would be the port that is now open. And what's the service name according to Nmap? And it's domain, right? Because 53 is the DNS. So domain would be the service name. And there we go. So we're officially done with that. And now we can talk about fine-tuning. So let's say you don't want to scan the top 1000 or the top 100. Let's say you want to scan a specific list of ports, the ports that are of most interest to you. You want to find out what services are running on all of those ports, and what versions of services that are running, or what versions of machines are running, etc. So if you were to do something called the SA scan, the SA scan scans for everything, right? So let's actually go into Nmap's manual, or I guess I should do man Nmap. So that's the first one. So if we were to look at the manual for Nmap, we'll get an options list. If we scroll down far enough, we'll get to see all of the various options that are available if we wanted to use Nmap. So let's scroll down a little bit. Under option summary, you get to see all of these things, right? So these are all of the option summaries. So specifying targets or host types of discovery, and then you can do scan techniques and port specifications, etc., etc. Now, when we go down here, you have the service version detection, which is done by SV. Hopefully you can see that. So let me zoom in a little bit more. Service detection is done by lowercase s, uppercase v. And then if we go over up here, I wonder if it's under these things, or where is it? Is it SA? It's either SA or -A, I think. It's like -A, I want to say. OS detection is -O. And then if we go to, let's see, miscellaneous, -A. Okay, there we go. It's -A. And when you do this, It does OS detection, version detection, script scanning, trace route, and a bunch of other things. So it's literally going to do all of the options. And this is going to take a very long time if you just by default say, I want you to scan every one of the top 1,000 ports. Or let's say you don't even do that. Let's say you do this option right here, the -P-, which ends up scanning all 65,535 ports. So if you do -P- and -A, it's going to take hours for the scan to finish because it's going to do all types of scans against all 65,000 ports. So to mitigate that, to make it a little bit easier on you and to make it a little bit faster, if you know that the most interesting ports to you and your exercise are SSH, HTTP, and HTTP3, right? You can then do -A against these 3 ports, and then it'll do all of the scans and everything that it does against only 3 ports, right? So you can actually give it a port list by just using these comma separators. You can also give it a port range. So you can do -P and then do 1 and then dash and then the next number, and it'll go between 1 and the next number. Or you can do -10, right? So, or you could, you could do -P 10 and then do another dash and then do 50. So it'll go between 10 and 50, right? So it's going to scan whatever the ports are between those 2 ranges, while doing 20 to 25 right here, you can see that it'll go to do anything between 20 and 25. So you can scan all the ports by doing -P- just like this, which will scan all 65,000 ports. It's going to take a really, really long time. If you want to do the common 100, you can do -F, which is what we did in the last one. Or you can do top ports 10, and it'll check the 10 most common ports, or top ports 50, and it'll do that. And again, you can control the scan timing using the -T and then give it a value. So it could be T0, for example, which would be the slowest, meaning it's going to be a very slow scan, but it won't show up. It's like the least likely scan type to show up on network monitoring logs. If you do T5, then it's insane, right? So it's super aggressive, and it's going to be very loud, and it's going to be very fast. Therefore, most likely, it's going to raise a lot of alerts on network logs. So when you do paranoid, you mean you really don't want to get detected. Sneaky is the next level, polite, and then there's normal, and then there's aggressive, and then there's insane. And typically, if you don't declare any of these values, it'll just go by normal, right? But if you want to be super slow, and if you don't want to show up on network logs, then you can do paranoid, right? So that's the timing of the scan, or the speed of the scan technically, in relation to how many packets are sent out, right? So to avoid intrusion detection system, you can consider T0 or T1, and it scans 1 port at a time, waits 5 minutes between sending each probe, so you can guess how long a scanning of a target would take to finish. So 5 minutes against 65,000 ports, you can imagine how long that would take. It's going to take days probably. So let's actually do that. So I'll even do this. So we will do 65,535 times 5. That ends up being 327,000 minutes. Okay, so 327,675 minutes. And we divide that by 60, and that gives us 5,461 hours that it'll take. And you divide that by 24, and it'll take 227 days. So it'll take 227 days if you do a T0 scan against all 65,535 ports. Now, if you don't specify any timing, it uses normal T3. If you use T5, it's the most aggressive in terms of speed, but it can also affect the accuracy of the scan results due to the increased likelihood of packet loss. So T4 is often used during capture the flag exercises and when learning to scan for practice targets. And T1 is often used during real engagements where stealth is much more important. Alternatively, you can choose to control the packet rate using the minimum rate number or the maximum rate number. So for example, if you do max rate 10 or max rate equals 10, it ensures that the scanner is not sending more than 10 packets per second. And you can control probing parallelization using min parallelism, and then you give it the number of minimum parallel probes, or maximum parallelism, and then you give it the maximum number of probes, and it probes the target to discover which hosts are live, which ports are open, and the parallelization often specifies the number of such probes that can be run in parallel, basically meaning at the same time. So if you do a minimum parallelism of 512, it pushes Nmap to maintain at least 512 probes in parallel. And these are related to the host discovery and open ports. So it's asking a lot of Nmap when we do that. So what's the option to scan all TCP ports between 5,000 and 5,500? So you would do what? You would do -P, and then you would do 5123, so 5000 -55000, or 5500, I should say. And that would scan everything between 5,000 and 55,000. How can you ensure that Nmap will run at least 64 probes in parallel? And so it would be minimum parallelism, this piece right here. So I'm just going to copy that part, and then we're just going to add the 64 at the end of it, which is that. And what option would you add to make Nmap very slow and paranoid? And that would be -T0. That's paranoid, so extremely slow. And that's pretty much it. So in summary, in this particular video, we covered 3 general types of scans. We have the Connect Scan, the SYN Scan, and the UDP Scan, and these were the commands that we assigned to them, or they were assigned to them. So ST, lowercase s, uppercase t, is the full Connect Scan. If you don't designate this, it'll just automatically do it unless you use sudo. When you use sudo, it uses Nmap, and then it does the lowercase s, uppercase s, meaning the SYN scan, also known as the stealth scan. And then if you do UDP, then it'll do lowercase s, uppercase u, and then it'll do a UDP connect. It's a connectionless scan, and it'll do a UDP scan for you. So these are the types of scans that will actually get you started using TCP and UDP services on a target. And then of course -P- would be all ports. -P1 to 1023 would scan everything from 1 to 1023. -F would be 100 most common ports. -R, lowercase r, scans ports in consecutive order. The T flag, or the T option, is the timing of the packets that are sent out and how frequently packets are sent out. So T0 is the most paranoid, and T5 is the most aggressive. So T0 is most likely going to be the least detected, while T5 will be the most likely to be detected. And then you have the max rate of 50, meaning send 50 packets per second maximum, or minimum rate of 15, send at least 15 packets per second. And then of course the minimum or max parallelism, which sends at least or at max the number of probes. So in this case, it'll send at least 100 probes in parallel. So that is pretty much it for our Nmap port scanning introduction. So I hope you got some decent value out of this, and you were able to run the exercises along with me so that you can practice Nmap and do the things that you need to do just to get a hang of the tool, because in the next episode and the one after that, we're going to be doing more advanced scanning, and we're going to be talking, we're going to review back to that initial diagram that we saw, that RCP, or RPC, request for comments, or RFC, there we go, RFC, that RFC diagram that we looked at, where it showed us the number of bits and the types of flags that we can set. And we're going to refer to that more frequently so that you can actually do some of the more advanced scans and everything else that comes along with Nmap. It's a very, very powerful tool. It is an industry standard. Everybody uses it, and it's something that you need to get good at using as we go along with Junior PenTester and as you go further into your penetration testing journey. So I hope you found value out of this thing, and if you have any questions or comments, make sure that you drop them in the comments section below. If you did get value out of this video and out of this room, I do encourage you to like, subscribe, and turn on the notification bell so that you get notified the next time that a video comes out on this channel, especially as we continue with Junior PenTester. And every Friday, there's a new video that comes out for CompTIA Pentest Plus, which is the advanced conversation around penetration testing. Make sure that you drop your comments in the comment section below, drop your questions in the comment section below. And there's a bunch of stuff that happened. This was actually the very first live stream stream that I did on YouTube earlier today. It was my birthday live stream, and we actually had a good turnout, even though it was a surprise and I didn't announce it to anybody. There were a lot of people that showed up, and it was really exciting. It was a really cool experience, and I'm going to be doing that more often. So again, make sure that you turn on the notification bell and subscribe and all that stuff. And then we have these other playlists that are available. So we have the CompTIA Pentest Plus playlist that's currently being built right now. We have Network Plus, which is already done. This is exclusive to the Hackaholics Anonymous membership community. We have Security Plus is already done. Linux Plus is already done. Network Plus is already done. There's CySec 101, which is another playlist that's really crazy. That is very, very powerful. So if you haven't done it, I highly recommend you go through this. This is very, very powerful, very fun, foundational. CySec hacking case studies. We have Hackaholics Anonymous exclusive SOC level 2 compilations, security engineering, and there's a lot of stuff. On the homepage, I have the SOC level 1, SOC level 2, and security engineering playlist available, and of course all the stuff that's available to members only. So there's a lot of stuff, and if you don't know which playlist the information that you're looking for is in, instead of browsing, you can just go to this search button right here, and you can search for the thing that you're most interested in, and then it'll bring up all videos that have to do with that topic for you. Currently, there are almost 400 videos that are available on this channel, 397 videos. It's pretty crazy. There's a lot of videos that are available on the channel, and there's more videos that are coming out, and I respond to the requests that are being made in the comment section, and I create videos around the stuff that you want to know about, so you can drop a comment if you want to learn about something in particular, and we'll do that as well. So there's a lot of stuff, and it's all accessible to you for free through this channel. And the only thing that I request from you is to like, subscribe, and turn on the notification bell so that you get notified the next time that a video comes out. And if you drop a comment, it helps us with the YouTube algorithm. If you're serious about your SysAdmin education and you want access to me on Discord, consider joining Hackaholics Anonymous. We have 4 tiers: the Supporter, Agent, Guardian, and Master. Each tier gets their own Discord server and early access to content. The Agent, Guardian, and Master levels get exclusive content, exclusive downloads, monthly Python automations, live streams with me every month, plus so much more. And to join, you can simply click the link in the description below, or you can go to our homepage and click the join button there, or you can go to youtube.com/@HankHacksHackers/join, and you will be able to join Hackaholics Anonymous. I hope I see you in the Discord chats. If not, I hope I see you in the comment section. And this is your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker/protector. If no one else loves you, Hank loves you. Love, peace, and chicken grease, and I'll see you in the next video later.